All right, so today we're going to be focusing on arithmetic sequences. Okay, arithmetic sequences, we're going to talk about what that is to be sequences. We're going to talk about what that means to begin with. That way you can recognize what an arithmetic sequence is, which is our first objective. Then we're going to use a formula to actually write the equation for an arithmetic sequence. And lastly, we are going to work on using that formula to find the common difference or any other requested value. So there are three main objectives for today. Before we start with our new stuff, let's do a little bit of review. So arithmetic sequences, these three things are all examples of what an arithmetic sequence looks like. So we have actually dealt with arithmetic sequences before, but not had a name to attach to them. So right now we're just going to review what we already know. So we're going to find the first 5 terms of each of the sequences. So that means we're going to have to find the first term, a of 1, which would be 1.4 times 1 minus 8. And we can go ahead and type that into our calculator. 1.4 times 1 is 1.4. Minus 8 will give us a negative 6.6. So that's our first term. Then we're going to find our second term by now plugging in 2 for n. So 1.4 times 2 minus 8. Type that into our calculator. 1.4 times 2 is 2.8. 2.8 minus 8 is negative 5.2. Then we're going to have to find our third term. So we're going to put 3 in the place of n. Be 4.2 minus 8 is negative 3.8 for our third term. And our fourth term, 1.4 times 4 minus 8, which if we type that all in our calculator at once would be negative 2.4. And then the same thing for the fifth term, so 1.4 times 5 minus 8. Well, 1.4 times 5 is 7, and 7 minus 8 is negative 1. So the first 5 terms are negative 6.6, negative 5.2, negative 3.8, negative 2.4, and negative 1. So this should look really familiar. We've done it before. You just plug in the number of the term that you want to find in place of the n. So for the next one, we're going to go through that same basic step, right? We're going to find the first 5 terms. So negative 10 times 1 minus 1. Or, I'm sorry, I missed that plus sign. So plus 1 minus 1 times 12. So if I were to simplify that, that'd be negative 10 plus 1 minus 1 is 0 times 12. Or you could type that whole line in your calculator and get the answer. 0 times 12 is 0. Minus 10 would be negative 10 as our first term. Then for our second term, negative 10 plus, now instead of n we're going to do 2 minus 1 times 12. So that would be negative 10 plus 2 minus 1 is 1 times 12. So that would be 12, and 12 plus a negative 10 would be 2. And then for the third term, so negative 10 plus 3 minus 1 times 12. Well, again, we do what's in parentheses first. 3 minus 1 is 2, so it would be negative 10 plus 2 times 12. Well, 2 times 12 is 24, and 24 minus 10 would be 14 as our third term. So for our fourth term, negative 10 plus 4 minus 1 times 12 would be negative 10 plus 3 times 12. So 3 times 12 is 36, minus 10 would be 26 for our fourth term. And then the fifth term, negative 10 plus 5 minus 1 times 12 equals negative 10. And then plus 5 minus 1 is 4 times 12. Well, 4 times 12 is 48. Minus 10 would be 38. So our sequence for the first 5 terms is negative 10, 2, 14, 26, and 38. Now again, notice we didn't add them together because we weren't finding a summation. We were just listing out the terms in a sequence, not in a series. So now you're going to go ahead and you're going to try number 3 on your own, and we'll check that together in class tomorrow. But now let's kind of talk about those terms that we were just finding. Every single one of these sequences above is what we call an arithmetic sequence. The reason why they're arithmetic is because they go up or down by the same amount each time. What I mean by that is this. If I'm trying to move from negative 6 to negative 5.2, wouldn't we just add 1.4 and then add 1.4 again to get to the next one, and then add 1.4 to get to the next one, and add 1.4 to get to the next one? So I know that this is an arithmetic sequence because I can add the same amount to the previous term to get the next term. The same thing happens here. Negative 10 plus 2, or negative, what would I have to add to negative 10 to get to 2? I would have to add 12. And 2 plus 12 is also 14. And 14 plus 12 is 26. And 26 plus 12 is 38. So I know these are arithmetic because we go up by the same amount each time. So an arithmetic sequence means that every term but the first is found by adding or subtracting a fixed amount to the previous term. Now, when we go to do problems, you're going to have to be able to identify, is this an arithmetic sequence or not? Because if it's an arithmetic sequence, we're going to have certain formulas that we can use on it. If it's a geometric sequence, then those formulas are going to be different. So you have to be able to identify it as arithmetic, and there's a couple of ways to do that. First of all, we can identify if it's arithmetic. So identify, maybe I'll use a different color here. So identify arithmetic. And there's two really different ways to do that. The first way is if you're given a series of numbers, or I should say given a sequence of numbers. Check if add / subtract same number each time. If you can add or subtract the same number each time to get to the next one, then you know you can apply the arithmetic sequence. The other way you can identify if you can use whether or not it's an arithmetic sequence is by looking at the expression. So if given in the expression, like in this case, 1.4n minus 8, so if given expression, there should be no exponents. If there's no exponents, then you can go ahead and use the arithmetic sequence. So in this case, my original one, 1.4 times n minus 8, it's all multiplication, and addition and subtraction, there's no exponents. Same thing here, no exponents here, so it's arithmetic, no exponents here, so it's arithmetic. So when we start talking about the different arithmetic formulas, you can use them if you can look at a set of numbers and they go up by the same amount, or if you're given an expression and that expression has no exponents in it. Now, we keep talking about this amount that it goes up each time, this idea that it's going up by the same amount each time or going down by the same amount each time. That amount is called the common difference. So the common difference is the fixed amount that the sequence increases or decreases by. Okay, the set amount that the thing increases or decreases by. So if I'm looking at this one up here, 12 equals the common difference because that's how much it's going up or down by. Whereas here we are going up by 1.4, so 1.4 is the common difference. So however much you're going up or down by to get from one term to the next, that's your common difference. And you should know that it can be positive or negative. So whatever you're going up or down by, if you're going down, it would be negative. If you're going up, it would be positive. So it can be positive or it can be negative. So when we're looking at these formulas, okay, when we're looking at an arithmetic sequence, there are formulas that we can use to help us identify pieces of it, or to solve it, or to write an equation for it. So the formula for an arithmetic sequence is a sub n equals a sub 1 times the quantity n minus 1, or plus, I'm sorry, the quantity n minus 1 times d, where the a sub n is the nth term in a sequence. What I mean by that is it's that the n, meaning any number, in any term number, meaning any term number. So this could mean the 4th term, the 5th term, the 20th term, the 80th term. If I put an 80 here, then it means what is your 80th, the value of your 80th term. A1 is the value of the first term, right? Because that 1 is there. So A1 is the value of the first term. N equals the number of the term. So if we say, sorry, that should not be an H, the number of the term. So if we said find a sub 8, we're looking for the 8th term, so n would be 8 because we'd put an 8 here as well as here. And d stands for the common difference. Remembering that that common difference is how much you go up or down by. Okay? So before, we just kind of guessed and checked to write an equation for the nth term. That's what we had been working on in the first two sections of this chapter. But now we actually have a formula to help us write it, but we have to make sure that it is arithmetic first. So when I look at this problem, I have to think, is there a set number that this is going up by each time? Well, if I add 6, I get to 6. Adding 6 to 6 is 12. Adding 6 to 12 is 18. Adding 6 to 18 is 24. So this I know is arithmetic because it's going up by the same amount. So we're adding 6 each time. That tells me that it's arithmetic. So first thing you need to do is first check that arithmetic. And we know that it's arithmetic if it goes up by the same amount each time or goes down by the same amount each time. Now that I know that it's an arithmetic sequence, I can go into this. So step 1 would be to identify parts from sequence. What I mean by that is this, right? We're trying to use this formula. A sub n equals a sub 1 plus n minus 1 times d. So if I'm going to write the formula, I need to know what each of these pieces are. So let's start out by saying a sub n stays variable. We're not going to put anything in its place because we're trying to write a general formula. So if you're trying to write a general formula, then that would have to stay the way that it is. So when I look at this one here, a sub n is just going to stay a sub n because we're trying to write a general formula. Then the next term I see is a sub 1, which means we have to plug in the first term. So in this case, my first term is 0, so I know a sub 1 is 0. So you have to identify what's your a sub 1. The next variable that I see in here is n. N also stays a variable, because again, we're trying to write that general formula. So a sub n will stay a variable, and so will n stay a variable, which means the only other thing I have to identify is what's the d. And remember, the d is the common difference. Right? So in this case, we said we were going up by 6 each time, so I know my d is 6. Now that I have the pieces, and I've identified those pieces, realizing that a sub n and n are going to stay variables, then we can do step 2, which is to substitute into formula. So in this case, my a sub n stays a sub n equals a sub 1, I can substitute in, is a 0, plus parentheses, remember the n stays the same, and the 1 is just a number, and in place of the d, we put the 6. Now that we've actually substituted in, now we're just going to simplify. Okay, so we're going to simplify this. So if I was going to simplify this, you should recognize that there's multiplication between these. So we're going to distribute this 6 into the parentheses, even though it's behind there, because it still is multiplication to get 6n minus 6. We still have the plus 0 equals a sub n. Now we've got our like terms that we combine. So we can say a sub n equals 6n. 0 minus 6 would be minus 6. And there is your formula for the nth term in an arithmetic sequence. Okay, so we're going to do one more together, and then you're going to try it on your own. So first step, make sure that it's an arithmetic sequence. So to get from -2 to 9, we would need to, well, we're going further negative, so we have to subtract. And from 2 to 9 is 7, so we'd have to subtract 7 to get to 9. Now, will that hold true? So is -9 minus 7 16? Yes, it is. And then we can check again. -16 minus 7 is -23. So I know, yes, that it's arithmetic. Sorry, I keep putting that backwards. Arithmetic. Which means we go to the formula. A sub n equals a sub 1 plus the quantity n minus 1 times d. So you're going to have to memorize this formula, because once you know that it's arithmetic, you need to have this memorized. Remembering that the a sub n and the n stay variables. So a sub 1 means what's the value of the first term? Well, we know it's -2. D is the common difference, which in this case is negative, so it would be a -7. And now we can substitute in. So a sub n equals, a sub 1 is -2 plus n minus 1. Now my d is -7. Now that I've substituted all that information in, we're going to have to distribute and solve. So this would be -7n plus 7. Don't forget to bring down your -2 out front and your a sub n. So now we can combine our like terms. -2 plus 7 is 5. So a sub n equals -7n plus 5. And there is your formula for the nth term in that sequence. So now I want you to go ahead and try number 5 on your own. And then start the next video after.